In this problem, we want to find a value of p that gives me a value of fby here and here, which is between 499 and 500 pounds. Now I can solve this system of equations using Matlab by putting them in matrix form. I have 3 equations and 3 unknowns, so I'm going to have a 3 by 3 matrix, a vector of unknowns, and then a 3-element column vector of constants on the right-hand side of the equal sign. So the first thing I need to know is what order I want my variables to be in this vector here. I'm going to call it fax is in the first element, fay, and fby. Now that I know what elements correspond to what unknowns, I can fill in the a and the b vectors. The first equation can be written just as 1 times fax, 0 times fay, and 0 times fby. That's equal to 0. Since fay and fby don't show up in this equation, I can just multiply them by 0 to get rid of them. The second equation is nothing times fax, 1 times fay, and 1 times fby is equal to p. The final equation has no fax in it, there's no fay in it, there's 5 times fby, and this is equal to 10 times p. Unfortunately, now we have a problem. P isn't known, so this is not a vector of constants. Now we can pretty easily solve this set of equations by hand to give a value of p that gives fby to be pretty much whatever we want it to be. But we're supposed to use Matlab. So let's take a look at using a brute force approach. No cleverness, no finesse involved at all. What I can do is just flat out guess a value for p. I can check with that value to see if fby is in the range of 499 to 500 pounds. If it's not, I can guess a new value for p and keep doing that. Now I just need to decide what kind of algorithm I want to use to guess my values and check them. So let's write a little bit of pseudocode. I think I'll start out with a really low value for p and just increment it by a little bit each time until fby gets to be over 499. So let's set p equal to 0. Then I'll calculate fby corresponding to that p, and I can do a looping structure to say that as long as fby is less than 499, I'm going to add a little bit to p. So increment p by a small amount. For that p, I'll calculate a new fby, and then I'll just keep doing that until fby gets to be greater than 499. Let's go to Matlab and implement this algorithm and see how it works. Now let's implement our algorithm in Matlab. I'll create a script file to do that in. The first thing I probably want to do is put a quick comment in here that tells me what order my unknowns are in. So the first one is fax, fay, and fby. I need to do this because Matlab is not going to keep track of which variables are which. I need to know which element in this vector contains which unknown. Now I said I was going to start out by initializing my value of p to 0, and I need to set my a and b matrices. Before I enter the loop, I need to solve this once to get my initial value for fby, so a backslash b. And then fby is going to be the third element of x. Now I've got the fby that corresponds to p equals 0. Now I can enter my while loop. The first thing I need to do is update p. So I think every time through this loop, I'm going to increase p by ½ pound. Now that I've updated p, I need to reset b and resolve for the unknowns that correspond to that p. So x is equal to a backslash b. fby is still the third element of x. And now I can end my while loop. I'll save this, go back to the command window and run it. Now let's check to see what my variables are. Let's see what FBY turned out to be. It's 500 pounds, which is within the range of 499 to 500. The value of P that gives me that is 250. So everything looks just hunky-dory. I can check my results easily from the original equation since this problem is so easy. The third equation was 5 times FBY is equal to 10 times P. If I set FBY equal to 500, then 2500 is equal to 10P, and P will be 250. Looks like my program's working. Now in this particular case, the equations are so simple that you can do that very easily. But a more complicated case in which you might have hundreds of equations, the brute force method is probably going to be the only way to go.